Hello class, this is lesson 12.1, the triangle proportionality theorem. So in this lesson, you're going to be learning about the triangle proportionality theorem and the converse of the triangle proportionality theorem. But let's kind of go into the first theorem. What is the triangle proportionality theorem? So let me kind of explain this diagram right here. So you have a triangle. If you have a line parallel to the side of the triangle, so let's say this line is parallel to this side of the triangle. Notice that this line intersects the other two sides of the triangle, intersects here and here. What this theorem tells us is that it divides those sides proportionally. So to sum up, if EF is parallel to BC, then we create a proportion. So we say AE over EB is equal to AF over FC. So this top piece over the bottom piece is equal to this top piece over the bottom piece. Now, knowing that we could create a proportion, we could solve for a missing variable. And that's what we're going to be doing in the first example. So the directions for the first example: find the length of the given segment, round to the nearest tenth. So the length they want us to find is CY. So what I'm going to do is I'm just going to put X to show that I want to solve for CY. Then you could create your proportion. So if we say the top over the bottom equals the top over the bottom, we could write AX over XB equals AY over YC. So here it is. And then substituting the values, we have 9 over 4 equals 10 over X. Then we cross multiply here. 9 times x is 9x, 4 times 10 is 40, and then we divide both sides by 9 and we get x equals 4.4. Now because we said x is equal to cy, then cy is also equal to 4.4. And that's pretty much it. That's how we're going to be using the theorem to find a missing piece using the proportion. So let's go over some problems. Now you could choose to pause the video and try to do these problems on your own, or you could just continue to play the video. But for the first example, they want us to find out what DG is. So this piece right here from D to G. So what I'm going to do is I'm just going to put an X right here. And I'm going to create that proportion. So remember, with the proportion, you have an equal sign in the middle and then two fractions on either side. So the way we're going to be doing this, so it's the top piece over the bottom piece, so EC over CF is equal to ED over DG. ED over DG. Then let's substitute our values. So we have 32 over 24, and that is equal to 40 over x. Then if you cross multiply, 32 times x is 32x, and 24 times 40, let's find out what that is. So that's 960. Then divide both sides by 32. And we get x is equal to 30. And because we said x was DG, that answers our question. Segment DG is equal to 30. So I do want to mention that the order in which you create your proportion does not matter unless you or only if you make sure that that order is the same for the other fraction. So when we created this proportion, we said the top piece over the bottom piece equals the top piece over the bottom piece. Well, what you could have said was the bottom piece over the top piece is equal to the bottom piece over the top piece. So as long as you still create that proportion where you have those two sides equal to each other, that should be fine. And I mentioned that just because for problem number 2, you have a choice of doing it PQ over QM or MQ over QP. It's the same thing. But we're going to put X for Rn. We're trying to find Rn. And I'm just going to do MQ over QP. MQ over QP is equal to MR over Rn. So then I have 8 over 5 is equal to 10 over X. I'm going to cross multiply. 8 times X is 8X. 5 times 10 is 50. Divide both sides by 8. And I get X is equal to, let's find out what 50 divided by 8 is. That is 6.25. So if X is equal to 6.25, then Rn is equal to 6.25. Okay, so now the last part of this lesson, we're going to look at the converse of the triangle proportionality theorem. Now, the converse, when you see the word converse, think of opposite. So, kind of going back to the triangle proportionality theorem, if we knew these lines were parallel, then I would be able to use this proportion. Well, with the converse, we're trying to prove if the two lines are parallel. So, given a triangle and a line that divides the two sides, if the proportion is equal to the other proportion, then we can say the two lines are parallel. So in this section, we are testing to see if lines are parallel. So in the first example, verify that the line segments are parallel. MN and KL are parallel. So we have to verify this. In this object, if we create our proportion, we could say JM over MK equals JN over NL. Then substituting the values, we have 42 over 21 equals 30 over 15. If I simplify these two fractions, I get 2 over 1 equals 2 over 1. Because these are equal to each other, they're proportional, then I can say that MN and KL are parallel. Okay, so in our first example, we're going to be doing that. So again, you choose however you want to create your proportion. So I'm just going to call this one VT over TR is equal to VU over US. So then I have 90 over 72 is equal to 67.5 over 54. So what if we reduce? We could try to reduce, or we could try to divide. So let's try to divide 90 divided by 72, and let's divide 67.5 divided by 54. So what I'm going to do first is 90 divided by 72. That gives me 1.25, and 67.5 divided by 54, and that's also 1.25. Notice that these two sides are equal to each other, so that means that TU, the way you write TU is parallel to RS, is you put TU, and then you put these parallel symbols, and then you put RS. Okay, and that pretty much wraps this lesson. So let's kind of look at the homework. We have lesson 12.1 homework. You're going to have a lot of questions where we have to find the missing length. So let me see if I can do a problem with you guys. Okay, so I'll do problem number 6 with you guys. So this problem right here. Solve for AN. Then, using the value, solve for AC. So what we want to do first is find out what AN, so what I'm going to do is put an X right there. And now, after I solve for AN, I could find AC by adding AN plus NC. So, creating our proportion, we're going to have Cn over Na equals Cm over Mb. So Cn over Na equals Cm over Mb. Then plug in the values and we get 10 over x is equal to 16 over 40. Cross multiply and I get 16x is equal to 400. And I could divide both sides by 16. And 400 divided by 16 gives me 25. X is equal to 25. So then I know that AN is equal to 25. Now to find AC, I know AC is equal to AN plus NC, which is 25 plus 10, and that is 35. So AC is equal to 35. And that's how you're going to be doing these problems. So find the missing variable, and then in this problem, I wanted you to find the total length. All right, guys, have a good day.